Okay, for our last little review, we're going to be looking at parametric, polar, and particle motion. And there's a really good chance that you're going to have an FRQ over either parametric or polar. And a lot of times it throws in a particle motion piece. So this one is from last year, 2023, and this was number 2. So number 2 tells you that it is a calculator question. So it says for 0 to pi, a particle is moving along the curve shown so that its position at any time t is x of t, y of t, where x of t is not explicitly given and y of t is equal to 2 sine t. It is known that dx dt is equal to e cosine t. At time t equals 0, the particle is at position 1, 0. So the first thing it wants us to find is the acceleration vector of the particle at time t equals 1. Well, remember the acceleration vector is going to be x double prime of t and then y double prime of t. Now we've got our calculator and we know x prime of t, so I'm going to say y prime of t is going to be 2 cosine of t, and then I am going into my calculator and in my, let me go to function mode. Okay, so in my y1, I am going to put my dx dt, which is e to the cosine of x, and then in y2, I'm going to put my dy dt, which is 2 cosine x. And so what I want to do is I want to do the derivative of each of those at the value 1. So my acceleration vector is going to be let's see, math 8, ddx. We're going to go into y1, and we're going to evaluate it at 1, which would be negative 1.444. And then we're going to do the same thing, but now we're going to go into y2. Oops. And we get negative 1.6829. So that would be our acceleration vector. And really, as long as you tell me what you're going to do, then you're good with your setup. Okay, it says for 0 to pi, find the first time t at which the speed of the particle is 1.5 and show the work that leads to your answer. So remember that speed is that Pythagorean theorem, the square root of x prime of t quantity squared plus y prime of t quantity squared. And so we want that to be equal to 1.5. So, well, these guys are in my y1 and y2. So I'm going to go back to my y equals, and I am going to do the square root, and I am going to do alpha trace y1 squared plus alpha trace y2 squared. So there is my speed value, and then I'm going to put my 1.5. Now, I really don't care about graphing my dx dt right now, so I'm going to take those off and just graph my speed and my 1.5. Now, we're looking between 0 and pi, so I'm going to set my window between 0 and pi, and I'm going to do a zoom 0 to make sure that I can see it. And so it said the first time t at which the speed of the particle is 1.5. So I'm looking for this intersection right here. And so that gives me a t value of 1.2544. So that would be at t equals 1.2544. Okay. And for part C, it says find the slope of the line tangent to the path of the particle at time t equals 1. So let's start with that. So slope of the tangent line would be dy dx, which would be dy dt divided by dx dt. So at t equals 1. So basically, we have x prime and y prime in our calculator. Those are in y1 and y2. So I'm going to come back here to that. And so then I'm going to go to my home screen. I'm going to build a fraction. I want dy dt first. So that is in y2. And I'm going to plug in a 1. And then on the bottom, I'm going to put dx dt, which is in y1, and then I'm going to put 1. I don't know if y'all can see this. And so that will be the slope of my tangent line, 0.6295. Okay, so that's the slope of my tangent line. Then it says find the x-coordinate of the position of the particle at time t equals 1. Well, remember the x-coordinate, this is what you want, is equal to what you have plus the integral. So what we have is we know that at time t equals 0, my x position is 1. So our x of 1 is going to be 1 plus the integral. Our two time values are 0 and 1. And we're going to put our dx dt in there. So that is going to be our setup. And then we can just use our calculator. So 1 plus math 9. We're going from 0 to 1. And then remember dx dt is in y1, dx. And so that gives us 3.3415. Could you see that? I hope you can. So 3.3415. Okay. So those were the two things that we asked for there. And then the last thing it says find the total distance traveled by the particle over the time interval from 0 to 5. So remember total distance traveled is going to be the integral of speed. So we're going from 0 to pi. And so it'll be the square root of x prime of t quantity squared plus y prime of t quantity squared dt. And so then we can just go into our calculator. Remember this expression we plugged in, it's part of y3. So I can just integrate y3. Let's see, can you see that? Let me scoot it over. Okay, can you see? There we go. All right, so I'm going to go to the home screen. I am going to do math 9, 0 to pi. I am going to do what's in y3 dt. And that gives me 6.0346. And that would be the total distance traveled. Okay. All right, so the next one is another parametric. It says a particle moved along a curve in the xy plane is at position x of t, y of t, at time t greater than 0. The particle moves in such a way that dx dt is square root of 1 plus t squared, and dy dt is natural log of 2 plus t squared. At time t equals 4, the particle is at the point 1,5. So again, I am going to go into my y equals. I'm going to clear out. I'm going to leave my speed in there just in case I need my speed, because I might as well leave that. So I'm going to put dx dt into y1, so that would be 1 plus x squared. And then dy2, I'm going to put dy dt, which is 2 plus x squared. Okay, so now it says find the slope of the line tangent to the particle's path at time t equals 4. So dy dx, we just have to state what it is. It's dy dt over dx dt, and we want that at t equals 4. So we are going to go into, I'm going to create a fraction. I'm going to do alpha trace, and we want y first, which is y2 of 4. And then on the bottom, we want our x, which is in y1. So 0.7010. All right, find the speed of the particle at time t equals 4 and find the acceleration vector of the particle at time t equals 4. So the speed of the particle is going to be the square root of x prime of 4 quantity squared plus y prime of 4 quantity squared. So, I should probably label this as speed. So let's see, I'll do that on my home screen. So we'll have y1 of 4 squared plus, open parentheses again, y2 of 4 squared. So 5.0353. So that is our speed. This is all calculator stuff. once you know the formulas. And your acceleration vector is going to be x double prime of 4, comma, y double prime of 4. I don't know why I put the square brackets. So we need to take the derivative of what's in y and x, and we do not need to do that by hand. We can do a math 8 d dx. Oops. We're going to do what's in y1, and we're going to do it at 4, so 0.9701. Remember, you only have to be accurate to 3 decimal places. I'm going to come back here and do y2, 0.4444. So that would be the acceleration vector. All right, next one says find the y-coordinate of the particle's position at time t equals 6. So this is, again, what you want is equal to what you have plus the integral. So what we have is at time t equals 4, the y position is 5. So we are going to do y of 6 is going to be equal to 5 plus the integral. Now that was at time t equals 4, so we're going to do from 4 to 6, and I like to put it as y prime of t dt. Now remember, y prime is in y2, so this, all we got to do now is plug it into our calculator. So 5 plus math 9. We're going from 4 to 6, and we are going to pull our dy dt from y2. And then we're going to put our dx, and we get 11.570. And then the last one on this one is find the total distance traveled by the particle from 4 to 6. So remember, total distance traveled is the integral of speed. So it'll be the integral from 4 to 6 of the square root of x prime of t squared plus y prime of t quantity squared dt, which, if I remember correctly, we put into y3. There's our speed. So that way we can just do math 9. Oops, let me get you off the screen. From 4 to 6 of what's in y3 dx, which is 12.136. Okay, so that was from 2022. The next one is another parametric from 2021. They haven't had polar in a while on the free response, so don't be surprised if you've got polar on a free response pretty soon. I would say for time t greater than 0, a particle moves in the xy position, x of t, y of t, and the velocity vector is t minus 1 e to the t squared and sine of t to the 1.25. And again, it gives you at time t equals 0, you've got a location. Find the speed of the particle at time t equals 1.2. So remember, speed is equal to the square root. It'll be x prime of 1.2 quantity squared plus y prime of 1.2 quantity squared. So I am going to put my x and y prime in my y1, y2. So it'll be x minus 1 e to the x squared. And my next one will be sine of x raised to the 1.25. Okay, so now my functions are in there. I'm going to come home and I'm going to do square root, open parentheses, I'm going to do y1 at 1.2 squared plus, open parentheses, I'm going to do y2 at 1.2 squared. And we get 1.271. All right, and then it says find the acceleration vector of the particle at time t equals 1.2. So the acceleration, remember, is going to be x double prime of 1.2, comma, y double prime of 1.2. Now, we already have x prime and y prime, so we just need to take one derivative. So let's see, we're going to do, I wonder if I did this up here. I know I did. Yeah. I'm going to do that, but I'm going to change it to 1.2. So 6.246. And then I'm just going to change this to a y2.405. Okay. Next one, find the total distance traveled. Do these not all start to look the same? Find the total distance traveled by the particle over the time interval from 0 to 1.2. So again, we're going to look at the integral of speed. So we'll have the integral from 0 to 1.2 of the square root. We'll do x prime of t quantity squared plus y prime of t quantity squared dt. And remember, I already have this expression in y3, so I am just going to do a math 9, 0 to 1.2, y3 dx, and I get 1.009. And the last one, we have find the coordinates of the point at which the particle is furthest to the left for t greater than 0, and then explain why there is no point at which the particle is furthest to the right. Okay, so furthest to the left and furthest to the right means we're talking about dx dt, because remember, that's your movement left and right. If we want furthest to the left, then we want dx dt to be a minimum, okay? So if we look at our graph, let's see, we are going between, or it's greater than 0. So let's see, what should I change my window to? Let's go 0 to 5. Let's see where that gets us. And I do not care about graphing my speed. Actually, I really only care about graphing my x dt. So let's go zoom 0. Okay, so we're gonna have to adjust here because see how this is all along the, so that's way too big. So let's go to, let's say 100, and let's do this one at -10. Let's see how that does. Okay, so obviously there's like a little minimum happening down in here if you look at it. So I am going to, actually, I want to know, let me back up. I want to know where dx dt is equal to 0. So I'm going to find that intersect. So I'm going to find that 0. Enter. Enter. All right, so my 0 is at 1. So I really want a min on x of t, not x prime of t. I want a min on x of t. Okay, so I want dx dt to equal 0, so that happens at t equals 1. That's what I just found. So if I do a sign chart for that at t equals 1, and remember, we start at 0. If I look at my graph, I'm negative to the left of 1, and I'm positive to the right of 1. So that means we are moving left, and then we switch and we move right. Now, there is no chance of this guy turning around and coming back. That's why there is no point furthest to the right. So we say furthest to the left is going to be at t equals 1. So I want the coordinates at t equals 1. So if I want the x and the y, let's see, for my x value, so x of 1 is going to be equal to, time t equals 0, here's my position, okay? So we're going to do it for both x and y now. So I'm going to do -2 plus the integral from 0 to 1 of x prime of t dt. And then y of 1, I'll go ahead and set it up, is going to be the y position at 0, which is 5. So I'm going to have 5 plus the integral from 0 to 1 of y prime of t dt. Okay, so now I just have to go find those. So I'm going to go home, -2 plus math 9, 0 to 1. we're doing x, so y1 of t dt. So that gives me negative 2.603. And for, oops, let me get this back on here, y, let's see, change this to y2 and change this to 5, and I get a y value of 5.410. So the point then is negative 2.603, 5.410. Okay, and it's a points in ordered pair, so it goes in parentheses. And then we can say, explain why there is no point at which the particle is furthest to the right. We're going to say x prime of t is greater than 0 for all t greater than 1. Therefore, it continues to move right and let's say doesn't turn around. That's good enough. Okay. All right. Now, next one we're going to look at is polar. Okay. So we are going to use we're still going to use our calculator. So it says the curve to the right is drawn in the xy plane is described by the polar equation r equals theta sine theta for 0 to 2 pi, where theta is measured in radians. The graph has an outer and an inner loop. It says find, it should be area, it's my typo, find the area between the outer loop and the inner loop. So like with everything, we're going to figure out where the outer loop or where the inner loop begins, and we're going to integrate. So let's see, we want the whole thing minus the inner loop. So let's see where we have, oh, we've got our calculator. So I'm going into y equals, I'm going to clear out what's there, and I'm going to put in function mode x sine x. Now remember, the inner loop happens when the radius is less than 0, so when the radius is negative. So remember, this is representative of our radius. So if we graph this from 0 to 2 pi, and let's just do a negative 10 to 10, we're looking for where our radius is negative, which is this piece right here. I don't know if you, there we go, which is this piece right here. So I need to figure out the zeros there. So that's at 3.14, so obviously that's at pi. So r is less than 0 between pi and 2 pi. So you go theta less than or equal to 2 pi. So my area is going to be 1/2 the integral from 0 to 2 pi of theta sine theta squared d theta. That's going to be the whole thing. And then we're going to subtract 1/2 the integral from pi to 2 pi of theta sine theta squared d theta. So remember, it's 1/2 the integral from alpha to beta of r squared d theta. So that's the formula we're using. All right, so go to my home screen. It's going to be 0.5, math 9, 0 to 2 pi. Let me get this where I can see, you can see it. And then, let's see, I have theta sine theta into y1, so I'm going to just use y1 squared dx minus 0.5, the integral from pi to 2 pi of y1 squared dx. So that gives me 2.1911. Okay? It says find any angles theta that correspond to the point on the curve with an x-coordinate of 1. Okay, so if we're talking about an x-coordinate, then we have to write an equation for x, which remember is r cosine theta. So for this instance, it would be theta sine theta times cosine theta. Okay, so that's our x-coordinate, and we want to know if that's equal to 1. So in my y equals screen, I'm going to come down here. There's my r. So I'm going to do y1 times cosine of x. That's my x-coordinate, and the value I want is 1. Now I'm going to not graph that guy. I'm going to graph those two. And we got 2 of them, so I'm going to second calc 5. I was looking to see if it was the first one or the second one. So it's 3.4507, so it theta equals 3.450. And then at my next one, second trace 5, inner, scoot over to this guy, 4.481. Okay, so those are the angles where the x-coordinate is 1. It says find the value of theta in the interval from pi over 2 to pi that corresponds to the point on the curve with the greatest distance from the origin. Okay, distance from the origin is represented by r. That's what r stands for, the distance from the origin. So between pi over 2 and pi, we want a max on r. So let's see where let's see what we want to do. Well, we've got a calculator. So let's go to y equals. Let's hit enter. Let me take care of those. And so we want a max on r. So let's go graph. And our max would be this guy right here. So I'm going to just find that. So second calc maximum. So enter. So our max is the ordered pair 2.028. And then 1.819. So it says find the value of theta between pi over 2 and pi. So that means my theta value would be my x value, which is 2.028. Okay, and their justification is that we want a max on r. All right, let's circle that. All right, a particle moves along a polar curve such as the position is x of t, y of t, and d theta dt is equal to 1/2. Determine that the particle is moving towards or away from the y-axis at the instant where theta is equal to pi over 6. Okay, if we're moving towards or away from the y-axis, that means we are moving horizontally. So we need to know, remember, the value of x of pi over 6, and we need to know dx dt at pi over 6. So those are the two things that we need to know. Well, x at pi over 6, we already have our equation for x in there. So that's in y2, so I'm going to activate it. So I am going to do alpha trace y2, and I am going to type in pi divided by 6, and I'm going to get the decimal 0.2267. So 0.226. So now I need dx dt. Well, this one I'm going to have to do a little work. So I know that my x is theta sine theta, cosine theta. So I want the derivative of that at pi over 6. Wait a minute, we have our calculator. So what I'm going to do is dx d theta times d theta over dt. When we take the derivative of x, our variable is theta. So when we do that, we're getting dx d theta. Then we want dx dt, so we're going to multiply by d theta dt. So it's going to be, let's see what dx d theta is. So math 8, d dx, our x is in y2, and we are going to be at pi over 6. So that would be 0.694 times 1/2, which would be 0.347. All right, so now our our x value is 0.226, and we are moving, our dx dt is 0.347. So this means we are right of the y-axis, and we are moving to the right. Okay, so if we're to the right of the y-axis and we're moving to the right, we must be moving away from the y-axis, because both x of pi over 6 and dx dt of pi over 6 are positive. You could also say they have the same sign. That would be the same thing. All right, so that is it with polar and particle motion. So I hope that makes sense. Again, if you have any questions, come see me. Bye, guys.